All right, Intro to Cal and Statistics. This is still 8.5 combinations. So my fancy pen isn't working, so we're just going to have to go through this and see what we can do. So you want to write this down. When you count the number of possible permutations of a set of elements, order is important. And I keep saying that. Permutation, orders matters. Combinations, not so much. So for combinations, you can have any order. You can have ABC, BAC, they're equal. Order doesn't matter. So, what does that mean? You would count only one of the two subsets. A common example of a combination is a card game, okay? And we'll be looking at lots of card games. So down here, we've seen this before, n chooses r. N chooses r is the number of combinations of n elements taken r at a time. Okay, so that's important to think about. It's n factorial over the difference between n and r factorial times r factorial. Like I said, you already know that formula. Let's look at an example. So this says, in how many different ways can 3 letters be chosen from the letters A, B, C, D, and E? The order of the 3 letters is not important. So since order isn't important, that means it's a combination. So down here, so sneaky, we have 5 chooses 3. The reason it's 5 chooses 3 is the 5 stands for A, B, C, D, E, the 5 letters we have. And we're looking for 3 different letters, so that's why we have chooses 3. So then you calculate it out and you get 10. See if you can come up with those 10 options. We'll look over those in class. That's your try this. Problem B says a standard pokered hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? And then there's a little note, after the cards are dealt, the player may reorder them, so order is not important. Order is not important, ding, 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 combination. So how many do you have to choose from? You have 52 cards to choose from. That's the number of elements, 52 cards. How many are you picking? 5. So you have, so tiny down here, let's zoom in a little bit. Whoa, where'd it go? So it's 52 chooses 5. So remember, it's n factorial, your 52, over the difference of the two of them times r factorial. Well, that's a huge number. There's no way you're going to write 52 factorial out. So remember your trick. You have 47 factorial. So go from 52 all the way to 47 factorial, which will cancel with the 47 in your denominator, and then you'll just have 5, 4, 3, 2, 1 in the bottom. Multiply those out, do a little fun canceling tricks, and you'll get 2,598,960. Obviously, I'm not going to have you write all of those combinations out, so the only try this you have to do is the last example, come up with all of the ways you can arrange those letters. You should have 10 of them.